All right, let's talk about one of those skills that every single Java developer has to master, handling files. We're going to dive into the modern way to do it using the java.nio package. It's all about reading, writing, and managing files, but doing it the right way, safely and efficiently. So, let's jump right in.
You know, this quote just hits the nail on the head, doesn't it? On one hand, reading a file can be a single beautiful line of code. On the other, you could accidentally create a security nightmare. And that's exactly what we're here to avoid. We're going to make sure you land on the one line of code side of things, not the nightmare side.
Okay, so why should you even care? It's simple, really. An application without data is, well, it's pretty much useless, right? It's just an empty box. File handling is what connects your code to the real world, to the data that actually makes it do something meaningful. It's not just important, it's absolutely fundamental.
And trust me, File I/O is everywhere. Just think about your daily life as a developer, or even just using a computer. You've got banking logs, config files that your apps need to start up, those giant CSVs you have to import for analysis. Heck, every time you upload a photo or sync something with the cloud, that's File I/O in action. It's the hidden plumbing of the entire digital world.
So in Java, you've kind of got two ways to tackle this. There's the old school java.io package. It's the original and it still works, but it's a bit clunky. It's what we call blocking. Then you have the new kid on the block, java.no. This is what we're focusing on. It's modern, it's robust, and it supports non-blocking I/O for serious performance. And my favorite part? The error messages are so much better. That alone will save you hours of pulling your hair out.
All right, let's meet the heroes of our story, Path and Files. Seriously, if you're still using the old file class, it's time for an upgrade. These two are your new best friends for anything and everything related to the file system in modern Java.
So what exactly is a path? Think of it as a smarter, more modern version of a file path string. The magic trick here is that it's operating system agnostic. You know the pain, right? Forgetting if you need a / or a / depending on if you're on Windows or Linux? Yeah, Path takes care of all that for you. It's just a clean, reliable way to represent a location on a disk, period.
And the advantages are, well, they're huge. We already mentioned the better error messages, which is a lifesaver, but your code also becomes instantly portable across different operating systems. It handles tricky things like symbolic links much more safely. And you can do what are called atomic operations, like moving a file where it's guaranteed to either finish completely or not happen at all, so you don't end up with corrupted data. It's just a way better, safer, and more pleasant way to work.
Okay, enough talk. Theory is great, but code is better. Let's get our hands dirty and see just how simple Path and Files make the bread and butter of file handling, reading and writing.
Check this out. You need to read a whole file into a string, maybe a config file or something small. Boom! One line. That's it. Files.readString, and you give it the path. It doesn't get any cleaner or more readable than that. It's almost too easy. But okay, what if the file is massive, like gigabytes of logs? You can't just load all of that into memory. Your application would crash and burn. That's where files.lines comes in. This is a game changer. It gives you a Java stream of all the lines in the file, so you can process them one by one. You're not loading the whole file, just a tiny bit at a time. It's super efficient and the right way to handle large files.
And writing? Just as simple. Files.writeString does exactly what you think it does. By default, it'll just overwrite the file. But what about appending to a log file? That's a super common use case. Easy. You just add one more little argument, standard open option.append. What I love about this is how clear it is. You're explicitly stating your intention, which makes the code so much safer and easier to understand.
All right, so we've nailed the basics. Reading and writing simple text is a piece of cake now. But let's level up and look at some of the more heavy-duty, real-world stuff you'll actually be doing in a production environment.
When people talk about high-performance Java, especially for networking or big files, they're talking about channels and buffers. This is the secret sauce behind the scenes. We're talking about applications that need to be incredibly fast and efficient, high-traffic web servers, video streaming services, even game engines. This is where java.nio goes from nice-to-have to absolutely essential.
So, let's look at a perfect example, copying a really big file, like a movie. The naive way is to read all the bytes into your program's memory and then write them back out. That's slow, and it uses a ton of RAM.
The smart way is to use file channels. You basically open a direct pipe from the source file to the destination file and tell the operating system, hey, you handle this. The data never even touches your application's memory. It's called a zero-copy transfer, and it is blazing fast.
Ah, the classic CSV import. Every developer has to do this at some point, and with the modern toolkit, it's actually elegant. Look at this flow. First, you use files.lines to get a stream. Then, you just chain your operations. You skip the first line, because that's the header. Then, for each line that's left, you split it by the comma. And finally, you do your work. It reads like a recipe, not a messy loop. It's just a beautiful way to process data.
And it's not just for files. Working with directories is just as slick. Files.list gives you a stream of everything inside a directory. And because it's a stream, you can immediately start filtering it. Want only the files, not the folders? Just filter it with files.isRegularFile. Easy. It turns directory traversal into a simple data processing problem.
Okay, let's pause. We've talked about all the cool, powerful things we can do. But now we have to talk about the most important part. And I mean it. Writing code that works on a good day is easy. Writing code that is robust, safe, and doesn't crash and burn when things go wrong, that's what makes you a pro.
Because, let's be real, the real world is messy. Files go missing. You won't have the right permissions. Some other program will have the file locked. Your server security settings will get in the way. Stuff breaks. All the time. And your code needs to be ready for it.
And this is how you handle it. You use a good try-catch block. But notice, we're not just catching a generic exception. That's lazy. We're catching the specific no such file exception. Why? Because now we know exactly what went wrong. The file isn't there. So we can handle that specific case. Maybe we log a nice message and create a default config. This is how you build applications that don't just die, they recover. Now, let's talk security. This is a big one. Imagine your code takes a file name from a user. They're supposed to enter something like profile.png, but what if a malicious user enters this string instead? Each one of those .. patterns tells the file system to go up a directory. They're trying to break out of the folder you want them in and start snooping around in sensitive system files. This is the classic path traversal attack, and it is seriously dangerous.
The scary part is the attack. The good news? The fix is unbelievably simple. Before you ever use a path that came from a user, you call one method on it. Normalize it. That's it. This brilliant little method cleans up the path, resolves all those tricky ... things, and gives you the actual final path. It completely shuts down this type of attack. Rule number 1, if the path comes from a user, you normalize it. No exceptions.
All right, let's do a quick flyby of everything we just covered. We saw how awesome java.nio, Path, and Files are. We looked at different ways to read files, from simple one-liners to memory-efficient streaming. We saw how easy it is to write and append. We even touched on high-performance I/O for massive files. We walked through a real-world CSV example, and then we wrapped up with the super important stuff, handling errors like a pro and securing your code.
And that really is the bottom line, isn't it? It doesn't matter if you're building a tiny desktop app or a huge, sprawling enterprise system. You're going to be working with files. It's unavoidable. So getting really good at these modern, safe techniques isn't just a nice-to-have. It's an essential part of being a great Java developer. So, I'll leave you with this. You've now got this powerful, modern toolkit in your back pocket. You know how to handle files the right way, the safe way, the efficient way. The only question left is, what are you going to build with it? Thanks for joining me.